So today we're going to be going over factoring quadratics. So the first time we'll talk about is if your leading coefficient is 1. That means in front of your x squared right here, there's no number. So if that's true, then you're going to be able to just jump straight to your answer. We're going to have x's here, and then the numbers we figure out are just going to go into these two spots here. So see, this one also looks like that. So the rule is, what are your factors of your last number, that's negative 28, I can add to get your middle number. You're looking for factors of negative 28 to give you the 12. And that will be negative 14 and a positive 2. They multiply to get negative 28. They add to get your middle number. And you just put those in the two spots right here, and you've now factored it. So let's try again. So again, we're going to find factors of the 48 that add to get negative 2. So that's going to be a negative 8 and a positive 6. So those numbers just go right here, negative 8 and positive 6. So our last one, factors of negative 10 to get 3. Negative 10 to get 3 would be a positive 5 and a negative 2. And make sure if that's an A that you're going to put an A down here too, whichever the variable is to solve it. If they ask you to solve, that means it's equal to 0 right here. Once you're done factoring, this is the answer we have factored form up there for this one. You actually need to set each parenthesis equal to 0. So you'd be solving this one equal to 0 and the x plus 2 equal to 0. So if you have minus 14, we'd always add 14 to both sides. Plus 2, you subtract 2 to both sides. Your answer is going to be x equals 14 and negative 2. Now let's try number 2. Your first step is to factor it. So the factors of 4 to get 5 were 4 and 1. You set each part equal to 0. You would subtract the 4 and subtract the 1. That gives us x equals negative 4 and negative 1 is our answer. Other types of factoring. So this is a special case where it tells you if you square root your a and your b, you're just going to put a plus and minus between it. So the idea I think here is, what are your factors of negative 25 to get to 0? Because your middle term is missing. So that would be a positive 5 and negative 5. And that was a 0. Again, set each part equal to 0. You get to negative 5, 5. So try number 2, the same trick. Factors of negative 6 to get 0. Negative 36 to get 0. So it was 6 and negative 6, and set each part equal to 0, and again, we would get a negative 6 and a positive 6. Now, 3 is a little trickier because we put a number in front of your x squared. You still just square root that number like we have been doing to the last number. So now, instead of just being x's here, we're going to have 4 x's. There'd be a 4x plus your 5 and your 4x minus your 5. And it doesn't matter which order you write these parentheses in, as long as you have both of them written down. So if you need to set this equal to 0, some of you guys can do it in your head, but if not, you just subtract 5 to both sides. You have 4x equals negative 5, and then divide both sides by 4. And you would do that for both sets of parentheses. You get a negative 5/4 and a positive 5/4 for this one. Your last one here, if I try to find factors of a positive 16, you see how this was a minus, and a minus? So positive 16 doesn't actually work. So a lot of kids will think, oh, how about x plus 4 and x plus 4? Well, if you FOILed out x plus 4 and x plus 4, you're going to end up with an 8x in the middle. So that won't work. If you try what we did here, a positive and a negative, that would make it a negative 16, not a positive. So number 4 is really what we call prime. It means you can't factor it. And the whole purpose of writing this on here was just to make sure you guys knew that a positive does not factor. It has to be a subtraction sign in the middle. All right, the last type in here is your GCF. That means the greatest common factor. Sometimes all you can do is to pull out what's common between your terms. So in the first one here, what's common is a 3x. I'm actually going to divide both terms by a 3x. So you divide the first term, you're left with an x. Divide your second term, you're left with a 1. And don't forget, you have to set each term equal to 0 and actually solve them. The first one gives you 0. The second one will give you a 1 here. Number 2, you're going to do the same thing. This time your GCF is just a u. Factor out your u, set each part equal to 0, and you should get 0 and 7. Our last one, sorry, there's 2 more. Your GCF between these two would be a 3x. So divide your 6 by your 3, and the 9 by the 3, and the x came out in front. So set each part equal to 0 if you need, and actually solve this. All right, so when you set each part equal to 0, you can see over here how I got the negative 3 halves and x equaling 0. So if you see down here, even a trinomial, sometimes all you can do is pull out your GCF. So a 5x is actually common in all three of those terms. If you divide all terms by a 5x, you get a 2x squared plus 2x minus 6. And if you try to factor this anymore, you will not be able to find factors of -6 to get a +2. So this indeed right here is actually the completely factored form.